Welcome back from an ad break. So before the break, we had questions that we're supposed to answer. So here are the questions again. We need to fill in the missing words in these sentences. So first question was saying, something which shows whether a substance is an acid or a base by changing color when we add it to that substance is called an. So we do know that indicators, they change color when we add them to either a basic substance or an acidic substance. So they are indicators. So it's called an indicator. Now B, the pH scale ranges from something to something. We do know that a pH scale measures the acidity or the basicity of the substance, whereby at 7, if the substance has a pH of 7, it's neutral. So if a substance has a pH of 0, it's a very strong acid. And should a substance have a pH of 14, it is going to be a strong base. So now that tells us that a pH scale ranges from 0 to 14. So this is what we know, that here it is neutral. So the pH scale ranges from 0 to 14. And then question C, our last question says, substances that have a pH that is less than 7 are called. We do know that from 0 to anywhere less than 7, our substances that are there, they are called acids. They are called acids. So learners, these are the questions that you have answered with the knowledge that you know about acids and bases. So throughout this entire lesson that you're going to be studying we are going to be looking at we're going to be using different ways to better explain the neutralization reaction, the acid-base reaction, and how do those things relate to each other. So you're going to be using words such as an acid, a base, neutral substance, and pH value in order for us to better explain the entire lesson in terms of it being a neutralization reaction or an acid-base reaction. So to begin with our first concept, as we have said, we are going to be looking at neutralization. And what is neutralization? When do we get neutralization? So to start, we know that strong acids and bases are corrosive. Remember, that means they can eat away flesh and any material that it come across. So that means now, whenever we have a strong acid or a strong base, those need to be handled with care. Remember, strong acids and strong base, they have an extremely either low pH or a high pH. So if a substance has a pH that is around 1, between 0 and 3 or 4, it's going to be a strong acid. Then towards the 14 there, 12, 13, and 14, that's going to be a strong base. At 7, it is going to be a neutral substance. So acids have a pH that is less than 7, as we have discussed. Any substance that has a pH that is less than 7, it is regarded as an acidic substance. Now the strength is going to differ in terms of the pH value of that particular substance. The closer it goes towards 0, the stronger the substance is. The same thing can be said about the base. However, bases have a pH that is more than 7. And the further you move away from 7 and closer to 14, the stronger the substance becomes, or rather the stronger the base is. Now, if an acid reacts with a base, they lose their corrosive properties depending on the strength of the reactant. So if we are reacting the acid and the base, now those substances are going to lose their corrosive properties depending on the strength of the reactant. Should we now react a strong acid and a weak base, the product that is going to be formed there will still be corrosive because our acid was stronger than the base. So for them to lose their corrosive properties entirely, the strength needs to match. The strength of the acid and the strength of the base, they need to match. So the product of the reaction between an acid and a base is salt and water. So whenever we're having a reaction between an acid and a base, the results or the products from there are going to be salt and water. So in terms of an equation, we are saying that an acid plus a base will react to form salt and water. So that's a word equation, a general word equation for the neutralization reaction or the acid-base reaction. Acid plus base will give us salt and water. Now the salt that is being produced there, it is going to be a neutral salt. So this mixture, as we have said, it is neutral. So the reaction that we are talking about here is called a neutralization reaction. The salt that we are getting as a result or as a product of acid and base, it is going to be neutral. So because of that, the entire reaction is called a neutralization reaction, because the acid and the base are going to neutralize each other in order to produce salt and water. So the products of those two are salt and water. Now, the product that you're talking about here, the pH of the salt will be around 7. And remember, if a substance has a pH of 7, then it is going to be a neutral substance. So the salt that you're going to be producing there when we are reacting an acid and a base is going to have a pH of around 7. Now, the amount or the volume of acid and the base mixed together is very, very much important. So we cannot just mix an acid and a base without not knowing their strength, and also without not knowing how much of each of those two substances we are mixing, because that is going to determine the product that you're going to be adding, that you're going to be having. So if too much acid is added and some of the unreacted acid remains, then the mixture will be below 7. So that means the mixture is going to be acidic. So in basic terms, if we are adding a large amount of acid with a small amount of the base, so if this is your acid and this is your base, obviously we do know that because we have more of an acid than the base, some of the acid is going to react completely with the base, and then there's going to be still some of the acid substances which are going to be left in that reaction at the end of the reaction. And because of that, the product will be acidic, because there's still some acid substances which are left there. Not all the acid reacted with the base, but then all the base reacted with the acid, and some of the acid was left because we added too much of it. We added too much of an acid. So now, the same thing can be said about the base, that if we are adding too much base, and some of the unreacted base is going to remain, then the pH will have, the substance or the mixture that is going to be formed there will have a pH of above 7, because there was too much of base added in that particular reaction. A small amount of an acid with a big amount, with a large amount of the base. So now all of the acid is going to react with the base, and some of the base is going to remain because too much of it was added. We can take, for instance, 1 liter of an acid and 5 liters of the base. Whenever we're trying to neutralize the two, we find that the 5 liters, not all of it is going to react. Some of it will still remain. So therefore, the product, the overall product is going to be still basic, because most of the base is still remaining in that particular reaction. So for the reaction to be neutral, completely neutral, the right amount of both the acid and the base, they need to be added. So they need to add the same amount of the acid and the base. So if the right amount of both acid and base is added, and both reactants are used up, so that means both reactants completely react, then the pH of the mixture is going to be 7, so it's going to be neutral. All the acid is going to react with all the base to neutralize each other. So, in addition to that, when we are talking about acid-base reactions, the pH of the product depends on the strength of the acid and the base. As we have said, the pH is going to be determined by the strength of either the acid or the base that we have added. If we've added a strong acid and a weak base, then obviously the strong acid is going to determine the pH of that particular product that is going to be formed. So if the acid is the stronger of the two between the acid and the base, then the pH of the acidic salt is produced may be between 5 and 6. And we do know that it's closer to 7, so therefore it's going to be a weak acid. Now, if the base is the stronger of the two, then the pH of the basic salt produced may be between 8 and 9. And remember, it's still closer to 7, it's around 7, but then it's going to be a weak base. However, the further you move away from 7, going to 10, 11, and 12, then we can talk about a substance being a strong base. And the closer we move towards 0, going to, let's say, 2, 1, and probably anything less than 1 but greater than 0, we can then say that substance is a very strong acid. Then, When we're talking again about the neutralization reaction, a reaction between an acid and a base is called a neutralization reaction, as we have said. Whenever we have an acid and a base that are mixed together, that are reacted together, that entire reaction is called a neutralization reaction. Now, an acid-base reaction or an acid-base mixture, it is not as acidic or basic as the individual starting solution. So the product that we are going to be having at the end of the reaction will not be as acidic or as basic as the starting points. So if we are having a strong base and a strong acid, the product formed there will not be either a strong base or a strong acid. It is going to be a neutral substance because we have strong and strong. Strong versus strong will neutralize each other. So we are saying that the mixture is not going to be as acidic or basic as the individual starting point. So if the starting point were strong acid and strong base, the product will not be a strong acid or a strong base. Right. And then the last thing that you also need to remember about the neutralization reaction is that due to the reaction, there is no longer an acidic or an acid nor a base mixture, but only salt and water. To reiterate again, when we are adding an acid and a base, the product will be salt and water. No longer an acid and a base as the product, but something completely different, being salt and water. And the pH of those products will be determined by the strength of the starting individuals, being either the acid or the base. So learners, before we go on to our next concept, we have said a mouthful. Let's just quickly go for an ad break, and I'll see you just after this.